Welcome to the presentation. My name is Prakash Chandra Chipa. I am a PhD candidate at Luleå University of Technology, Sweden. Today I'm briefly talking about the research paper Functional Knowledge Transfer with Self-Supervised Representation Learning. So coming to the problem statement, in general, self-supervised representation learning is achieving quite a new milestones without using human supervision. However, in the current time, we could see that it required large amount of training data. For the examples like ImageNet is a typical example with 1.2 million images. Second observation is that it required large batch size, which means we need a heavy computing systems. So with those two challenges, it is almost remain inaccessible that self-supervised learning could be applied for small scale data sets. So this is the exact research gap we would like to observe and identify the solution in this research paper. So we make here a hypothesis where we would like to emphasize on shifting the representational knowledge transfer paradigm to the functional knowledge transfer, which means that in general, the self-supervised representation models are used in two stages. First, we pre-train and then we utilize the knowledge transfer in the downstreaming task. In this, we make a hypothesis where we would like to jointly optimize self-supervised representation learning with the supervised task. And why we think that it should work? Because it is proven that self-supervised representation learning provides invariant representations. However, in case of a lack amount of data in smaller batch size, it might not be able to approximate the distributions to learn the effective representation, and that should be compensated by the supervised task by reinforcing the robust semantics. So the method we employ here, we utilize the contrastive learning from self-supervised method, and we combine it with the classification task here. So we jointly optimize the loss for contrastive learning and the cross entropy loss as in a method here. So the investigation protocol is that we identify few small scale data sets. For example, we pick three different data sets like a CFAR, Intel Images, and Aptos. Then we choose the self-supervised representation learning method, which is contrastive learning from SimCLR paper. And then we conduct the experimentations where we compare the representation learning and functional knowledge transfer. And the final part is to perform the performance evaluations in terms of quantitative analysis and the qualitative analysis. So coming to the dataset part, so we choose all three datasets from a different diverse domains. You could see the CFAR is a quite a single object oriented datasets where the Aptos coming from the medical images, fundus images, which talks about diabetes retinopathy severity level. And the third, the Intel images, is the natural scenes. So coming to the result part, here we could clearly see that by implementing by observing the comparative analysis between the representation transfer and functional knowledge transfer, we could see all three data sets. It's majorly functional knowledge transfers performing much better in across all the different matrices. We could see that. So that gives a validation, a quantitative validations for the hypothesis about the joint optimizations of self-supervised methods with the supervised task. If we compare the results with the state-of-the-art methods, so there also we could see that we are able to achieve much better performance than the previous method for the major of the most of the data sets here. And in order to understand the improvement in the results when we perform the qualitative analysis, so here you could see the two different examples from these two different data sets. So, in nutshell, we could understand that the functional knowledge transfers, the representations are equally good or even much better than the representational knowledge transfer, which means that model is being first self-supervised and then supervised. And so we could see here the clear comparisons where why the results in the quantitative analysis seems to be improved, because it model is able to attend the important reason by its own, learning the robust representations. So with this aspect, we are able to understand that self-supervised learning is we are able to make it work for the small scale data sets, for even a smaller batch size. So here in all the experiments, we have utilized 256 batch size. And last, come to the conclusion part. We contribute. So the contribution is we introduce the functional knowledge transfer to overcome the inaccessibility of self-supervised learning due to the small scale and the small batch by formulating the hypothesis of joint optimizations. From the achievement perspective, we could see that on the downstreaming task, we are able to achieve higher performance, which is well explained by the qualitative analysis. Coming to the future work, it would be interesting to explore this hypothesis further with the different self paradigms and also with the different computer vision tasks. With that, I thank everyone for your time. And if you have any further query and in general interest, please pass by to my posters and please check out the full paper. Thank you so much.